All right, class. Today we are going to get into the math side of pH. We'll be able to define pH and calculate pH using concentrations of H plus or OH minus. And we'll be able to perform the reverse operation with 80% accuracy. We're also going to be able to identify common strong acids and bases and calculate the pHs of their aqueous solutions given their concentrations. The quest that goes with this is the acid-base chemistry number 2. All right, pH. I'm just going to throw all of the equations at you because they're all related, which is nice. So pH is equal to the negative log of your H3O plus concentration. That is your hydronium ion. You can also use that interchangeably with H plus. So whenever you see H plus or H3O plus, I'm talking about the same thing. pH stands for the power of hydrogen. So the lower the pH scale is, so the closer it is to 0, the more acidic it is. The closer it is to 14, the more basic it is. All right. Now, if you remember, on the last play pause that we talked about how we have Kw, which is the equilibrium constant for the auto-ionization of water. Since that is equal to 1.0 times 10 to the negative 4. If we try and take the log of everything, it actually causes us to get a more linear scale than what we have before. So we can rearrange, set things equal to each other, and we can end up finding out that negative log of our H3O plus concentration plus the negative log of our OH minus concentration is equal to 14. Right? If you take negative log of 1e to the negative 14, we get 14. So that's where the pH scale comes from. They basically took the log of everything. Okay. We also know that because of this, if the pH is equal to negative log of H3O plus, we also know that POH is equal to the same thing. So we've got POH equals negative log of OH minus. This is the power of hydroxide. If we have pH and POH and we add them together, we will get a total of 14. Remember last time we had that example where if we were at 1e to the negative 7th, we were neutral. Well, if we take negative log of 1e to the negative 7th, you get 7. So it makes sense that when we're neutral, they balance each other out. So it also makes sense that if we were to add up those concentrations, they would always add up to 14. Okay. So the pH for nitric acid solution is 2. We want to know what is the concentration. Well, this is all an application of our pH equation. So we know that if pH is equal to negative log of my H plus concentration or my H3O plus, and I wanted to solve for that, I could rearrange it to say log of my H plus is equal to negative pH. And then to get rid of the log, I could raise it to the power. So I could say that this cancels out, and I end up getting the concentration of H plus is equal to 10 raised to the negative pH. So I'm going to do just that. I can say concentration of H plus is equal to 10 to the negative pH. I'll plug in my pH, and I get 10 to the negative 2, which 10 raised to the negative 2 is 0.010 molar. Now, this we got to be careful of because the question asks, what is the concentration of the nitric acid? So the entire thing. This is just the concentration of H plus in our solution. So we need to always go back and check our formula and see what the mole ratio is. Thankfully, the mole ratio of H plus to nitrate is 1:1. So this would be our correct answer. Okay, let's do the same thing. This time pH is equal to 10 for calcium hydroxide. What is the concentration of my calcium hydroxide? So I'll set you up. Same relationship. This time it's with hydroxide. If we have our hydroxide equation, that concentration is equal to negative pOH. So we know that our pH plus pOH is equal to 14, right? So if we plugged in our pH and solved for pOH, we'd be in good shape. So 14 minus 10, we get a pOH of 4. Okay. Then we could say 10 to the negative 4 is our pOH. 10 to the negative 4 is our OH concentration. And I could leave it like that, moles of OH. But again, I wanted the concentration of calcium hydroxide. So if I want my concentration of calcium hydroxide, I now have to look at the moles of everything. Okay. So I know that OH minus equals 10 to the negative 4th molar. But how many moles of hydroxide do I have for every 1 calcium hydroxide? Well, I know for every 1 calcium hydroxide, I've got 2 moles of OH minus. So I've got to do some stoichiometry a little bit, but that's okay. So 10 raised to the negative 4th, and I'm going to divide by 2. And I end up getting a concentration of 5 times 10 to the negative 5th molar calcium hydroxide. Okay. Last one's easy. You've got this one on your own. pH of 0.010 molar perchloric acid. What is that pH? Okay. Well, we know pH is equal to negative log of our H plus concentration, negative log of H plus. Thankfully, our ratio is 1:1 here. Uh-oh. Seem to have lost my... Oop. Okay, so luckily our ratio is 1:1 here. So we can just plug in negative log of 0.010, and sure enough, we'll get a pH of 2. So 0.1, our pH is 2. Okay, not so bad. All right, so what is the hydrogen concentration in aqueous solution whose pH is equal to 3.72? All right, go ahead and solve this one on your own. All right, it's just like the ones we just did. We know that H plus is equal to 10 to the negative pH. Let's plug it in, and you've got 10 to the negative 3.72. And 10 raised to the negative 3.72. We get 1.9 times 10 to the negative 4th molar. Make sure you put your units on that because it is a concentration, okay? All right, next one. What is the pH of an aqueous solution of hydroxide? Ooh. All right, this one's 2 steps. So, all right, we've got our hydroxide concentration. I know pOH equals negative log of my hydroxide concentration. So I'm going to do it. Negative log of 6.0 times 10 to the negative 3 molar. And negative log of that, what does that give me? 6E negative 3. Alright, that gives me 2.22 as my pOH. So we got to be careful, we're not quite done yet. What do we need to find? We need to find pH. So remember, pH plus pOH is equal to 14. 14 minus 2.22. So 14 minus pOH will give you my pH. So 14 minus 2.22. Sorry, make sure I put in the numbers right. And my pH is going to be 11.78. All right. Is this a basic solution or an acidic solution? Or is it neutral? It's a basic solution. It's over 7, over a pH of 7. Okay. So we can also just deal with this equation exclusively. If we're given a concentration of 1, we can take it both directions. So this is some good practice here. Using this equation and also the pH and pOH equals negative log of your concentration, go ahead and calculate A and B. So A, we have 1.0 times 10 to the negative third molar hydroxide. Calculate pH and pOH for both. Okay, so pOH is equal to 3. And then we know that 14 minus 3 gives us 11, so the pH is equal to 11. All right, try this for B. Okay, so negative log of 1. Anytime you do negative log of 1, you get 0. So pH is 0. If pH plus pOH is equal to 14, pOH has to be 14. All right. One more practice problem. Calculate the pH of 5.0 times 10 to the negative 2 molar sodium hydroxide. Okay. Well, negative log of my concentration. I have to be aware that this is a hydroxide concentration, right? So keep that in mind. So what I'm really finding here is pOH. All right. So if I'm finding my pOH, there you go, negative log 5 e to the negative second. I've got a pOH of 1.30, which means pH is 14 minus 1.3. I've got a pH of 12.70. Alrighty. On to the next one. So the pH of a sample of human blood was measured to be 7.41 at 25 degrees Celsius. That's slightly acidic, but okay. Calculate pOH, H plus, and OH minus for the sample. You got to do all of them. Okay. Well, the easy one's pOH. So we got pOH. It's equal to 14 minus 7.41. 14 minus 7.41, we know pOH is equal to 6.59. So then the concentrations of H plus and OH minus are going to be easy now. You've got 10 to the negative pH, and you've got 10 to the negative pOH. And you have both of these. So plug them in. We've got 10 to the negative 7.41. And we got 10 to the negative 6.59. All right. So we got 3.89 times 10 to the negative 8th molar for my H plus, and 10 raised to the negative 6.59. We got 2.57. 2.57 times 10 the -7th molar. All right. So go ahead and calculate the next two on your own. Pretty easy. You're given a concentration. What are my pHs? So A, nitric acid, 0.10. Okay. Negative log of 0.1. Alright, negative log of 0.1 is 1. Now you might want to get used to practicing some logs on your own, especially simple numbers like this, so you don't have to do it in the calculator. I'm showing it to everyone in the calculator just so that you are aware of the calculations. So you got log 1e to the -10th, it should be 10. Spoiler alert, it's 10. So I didn't even need a calculator for it, but you can check. If you're comfortable with that, go ahead and use it. You'll probably have some multiple choices where you'll have to do pH calculations like that, but have to use mental math. So keep that in mind. I would start practicing logs if you're not sure about logs and the rules for logs. And that's all. Have a great day.